This actually expands the case structure, so you have more space available inside it. As you can see, the whole loop also expanded with the case structure, so maybe we don't need the loop to expand that much. It needed to expand, but maybe not that much, so we can maybe reduce it somewhat in size. And this lower part we will use to do the covered distance calculation, so in meters. What do we need to calculate the covered distance? Well, we need to know how much time has elapsed and which speed we were moving at during that time. So actually at the moment we don't have any timing control, so we don't have any control over the time in this simulation. Since we are relying on time to calculate some of the parameters, this is not a good idea. So actually, whenever you have a loop and you don't need it to be running as quickly as possible so that it gobbles up all the processor time, it's a good idea to use some timing function, and this can usually be done by using the wait function. So what this function does is, when you create a constant and connect it to the input of this function, so let's say 50 milliseconds to wait, this actually counts up to from 0 to 50 milliseconds, and it does not allow for the loop to go forward to the next iteration if this time that we have declared here, the 50 milliseconds, has not passed. So only when the 50 milliseconds have passed, and if anything else is not running still, can the loop go to the next iteration. If the 50 milliseconds pass, but there is also some other code that continues on working after the 50 milliseconds, the loop will still wait for the other code. But mostly this does not happen, and especially in this case, because this is all just very simple code, so the 50 millisecond is here to make the program run slower actually, but also to give you some control over the time so that you can measure the time it takes for the process to go forward.